Hi guys, welcome to Sigma Maths. In this video we're going to have a look at some of the more advanced trig in the GCSE. If you are not already feeling very confident in your Pythagoras and you're applying sine, cos and tan to right angle triangles, so that's SOHCAHTOA, we will be releasing videos on those topics, so make sure you check those out before you come back to this video. Now before we start, I just want to talk about the type of triangles that we're going to be encountering when we're using these rules. The trigonometry that you've done already is only allowed to be used on right angled triangles. These new ones are going to be you're going to be able to use them on any type of triangle, but we need to make sure that we label these triangles correctly. So on the screen you can see that I have a generic non-right angled triangle. You'll notice that the angles are labelled with capital letters. We usually go with A, B and C. And that our sides are labelled with lowercase letters such that each lowercase letter is opposite the equivalent uppercase letter of the angle. So my lowercase a side is opposite my capital A side. We need to have this set up in order for the formula that we're going to use to work correctly. So please bear that in mind when you're doing questions. Now to keep this video short, I am just going to go through how we get to the sine rule, the cosine rule and the half AB sine C formula. I'm not going to be doing any practice questions in this video. I will do a separate video where I'll go through a variety of questions on this. Okay, so we're going to start with the area formula, and to begin we will write down the area of a triangle that we already know. So a half times base times height. So to relate that to the triangle that we have here, we've already got our base labelled as B, rather conveniently, because it's opposite angle capital B. And I've also drawn in this line here to represent the height, because when you use the half base times height formula, the height must always be perpendicular to the base. So I'm going to label this H. I'm also going to point out that we have right angles here due to the height being perpendicular. Now, we need to be able to rewrite this formula in a way that involves some trigonometry, and the idea here is that we'll be able to find the area of a triangle without necessarily knowing its perpendicular height. So if I focus on this larger right angle triangle that's been formed within the overall triangle, and I focus on the angle C, then I can write down a relationship between the angle C, the height, and A, which is the hypotenuse for this right angle triangle, because they all link together with sine. So I can write sine C equals H, opposite, over A, our hypotenuse. Okay, I can rearrange this slightly to replace, or so that I can replace the H here in the area formula with A sine C. So I can now come back up to the area formula, and this becomes a half times base times A sine C, with just a slight movement around of things because we like things to be alphabetical, just moving the A in front of the B there. A half AB sine C. We have the area formula. One of the main things to note about this formula is that you are always using the two sides that are opposite the angle. So if you're trying to find the area of a non-right angle triangle and you've got two sides in an angle, you need to make sure that they are the two sides either side of the angle, not the side opposite the angle. If you do not have the two sides that sit either side of the angle, then you will need to do some other process, possibly the sine rule or the cosine rule, to find out the sides that you need. So just bear that in mind. Follow these letters. That's why I said earlier that the labelling of the angles and the sides is very important. Okay, so let's move on to the sine rule. So I'm going to relabel with my height and my right angles. Okay, this time we're going to look at both of these right angle triangles and each of the angles A and C. Now it is the sine rule, so we're going to be using the trig function sine. So if we focus on the smaller right angle triangle, for angle A, the opposite is H, the height, and the hypotenuse is C. So I could write for this triangle, sine A equals H over C. For the other, the larger right angle triangle, I could write sine C is h over a. So again, opposite over hypotenuse. Now I can make h the subject of both of these, and the reason that I want to do that is because I know that they are the same letter. I can equate these two things because I know that h came from the same place. It was the height of the original triangle. Also, is the only letter, the only unknown here, that links these two equations together, because this capital C and lowercase c are not the same c, neither are the a's, so h is the only thing that is in common between these two equations. So seeing as they are both equal to h now, I can come up here and I can write, that means that c sine a is equal to a sine c. A slightly nicer way of writing this is to bring the a's together on one side and the c's together on the other side. So that means that I can either keep my sine functions on the top, so I can divide down by the a on that side and divide down by the c on this side, or I can do the dividing by the sine functions, leaving my c, lowercase c and lowercase a on top. So I could have a over sine a equals c over sine c. The reason I might want one of these forms over the other would be down to what I was actually trying to find. If I was trying to find an angle, then I would most likely use this formula, because it has my unknown would therefore be in a numerator, which is much more easy to deal with. If I was looking to find a side, then I would probably want to use this version of the formula, because then again my unknown would be in the numerator. Now we can actually extend this rule, this equation, to include b as well. So I could have arrived at having the sine b over b as part of this if I had just used a different side of my triangle to be the base. Okay, could have done the same thing but with the triangle turned over, so I can get exactly the same ratio with b. You won't ever use all three parts of this equation, you'll only pick the two that are actually relevant to what you're trying to find. And just to note, it is always a side and the angle opposite that go together in one of these fractions. And there is the sine rule. Okay, moving on to the final one for this video, cosine rule. Now this one's probably the hardest one to do the working for, to show how we arrive at it. And this isn't just about understanding where these harder formulae come from. There is always a chance that the exam board could ask you to actually prove these formulae or show where they came from in the exam as one of the harder questions. So you want to at least have seen how this works before, so that you've got some hope of reproducing it in the exam. Okay, so cosine. Now we're going to do the same thing that we did for the sine rule. So we're going to look at the two right angle triangles that we have by splitting it down the middle. Well, it's not really down the middle, but by splitting it down on the height. We're going to look at angle A and angle C. Although actually I'm probably not going to use both of those. And this time we are going to focus on using Pythagoras to begin with. Now the reason that we're doing that is that we need to make a link with these lengths down the bottom. So far we've only been using sine, which means we've been using h as our opposite and then a and c as our hypotenuse. In terms of the base, we don't know where this base is actually split. So the height comes down and hits here. B is the entire length. So what we're going to have to do in order to move forward here, seeing as these sides are the ones that are adjacent to the angles, is label one of the distances with x, which therefore means that the remainder of this base would be b minus x. That then means that I can write Pythagoras down for the small right angle triangle, so that would be x squared plus h squared equals c squared, and I can write it down for the larger one. So this would be b minus x all squared plus h squared equals a squared. So I've used these right angle triangles to write down a relationship between the sides involved. Now, looking for something that is in common in both, the h squared would be the easiest thing. I know we've got x's in both, but there's going to be some linear terms coming out of this bracket, so it's the h squared that we want to use. Like we used the h in the sine rule to link the two equations together, we're going to do the same thing here. So I'm going to make h squared the subject, so I'll get c squared minus x squared here, And if I make h squared the subject on this one, then I would have a squared minus b minus x squared. Okay, so similar thing as last time, both equal to h squared, therefore they must be equal to each other. So c squared minus x squared is equal to a squared minus b minus x squared. So all we're doing here is trying to come up with a relationship between the sides of this triangle and allowing ourselves the ability to use these sides down here, which will then allow us to use cos. So we know we're trying to aim to bring cos into this, which you will see in a moment, but let's just finish off tidying this up first. So c squared minus x squared equals a squared minus, I'm going to keep the brackets here, not the initial brackets, but I'm going to keep brackets because this whole expression is going to be subtracted. So I need to remind myself that that negative there is going to apply to everything inside the bracket. This bracket is squared, so I'm not going to write b squared minus x squared. I'm going to remind myself that I need to do a double bracket expansion. So what am I going to get? B squared minus xb minus bx, so that's minus 2bx plus x squared. And then I can go through and subtract. So let's have a look. We're going to get minus b squared plus 2bx and then minus x squared. Okay, the minus x squareds on both sides can cancel. And now, if you have seen the cosine rule before, you'll know that it begins with an a squared. And if you were trying to prove the cosine rule in the exam, then you would have the formula already in front of you, so you'd know what you'd be aiming for. So I know we're aiming to have a squared as the subject. So I'm now going to rewrite what I've got so far with a squared. So it's like I'm leaving it on its own on this side of the equation and moving everything else over to the other side. But then I've written, and then I'm flipping them all over, so I've written a squared on the left and then whatever I end up with over here on the right. So to get a squared on its own, I'm going to need to add this b squared over to the other side, so it cancels out. So I'm going to have a b squared, and then I've still got my c squared over there, and then this term is going to need to be subtracted, minus 2bx. Right, so we've got this equation almost entirely in terms of the sides of this triangle. The only thing that is not in terms of it is this x. So we need to find a way to rewrite this x, and that's where the cosine part comes in. So if we come over to the smaller right angle triangle, then we can actually link x with side C and angle A using cosine. I'm just going to write it up here. So we will have cos of A is adjacent, which is x, over the hypotenuse, which is C. Rearranging that, we get x equals C cos A. Now this can be substituted in place of x over here. So that will lead us to have a squared equals b squared plus c squared minus 2b c cos A. So I've replaced the x there with c cos A. And now we are done. We have the cosine rule. Now, things to note about the cosine rule, well, whatever side we start on here, so here we're starting with a squared, you will end in the same letter, so the opposite angle to that side. You can rewrite the cosine rule with any of the three sides in the front. I'll give you one example here. So if I started with b squared, then here instead I would have a squared and c squared. Then I would have minus 2ac, and then I would have cos b. So we start and end in the same letter, but obviously one's a side and one's an angle. And then these bits in the middle are just the other two sides squared and added together, and then multiplied by each other and pop here between the 2 and the cos. Okay, so you can change this around depending on how you've labelled your triangle and which side or angle you're trying to find. On the subject of finding an angle, you do have a choice here. You can either sub in your three sides and then rearrange to find the angle. Can be risky because there can be some mistakes made with the numbers, or you can learn the rearranged version of the formula. So if I take the original formula that I got to and make cos A the subject so that it's easier just to plug everything in and find your angle, then I would have, so let's think about this, minus 2bc cos A is the term that contains the thing that I want. So that whole part I would move over to the other side to make it positive. So I would have 2bc cos A, so I've literally just moved the term that contains what I want to be positive. I've still got the b squared and c squared on the other side, and I would take away the a squared because that's not part of what I want. And then that just leaves me with dividing by this extra bit in front, the 2bc. So I would have b squared plus c squared minus a squared all over 2bc. So this would be the rearranged form of the cosine rule used for finding angles. Okay, so that was a little bit more involved, that one. So we're just going to have a look at a summary of everything that we have seen so far, and there's a few things that I would just like to note. I think I've mentioned everything that I need to about the area formula, the fact that we always need the two sides either side of the angle. The sine rule, I'm trying to think of it. Oh, there is something that I want to tell you extra about the sine rule, which actually links in with the cosine rule. You kind of need to know which one you're going to use. Okay, the area formula is fairly easy to know that you're going to use it because there's some mention of area in the question. If there's no mention of area and you're just trying to find a side or an angle, then you're going to need to know which one to pick. So if we have a look at the sine rule formulae, we take like any two parts of this that we would actually use. We have, including the thing that you'd be trying to find, two sides and two angles. So that's how you're going to identify that you're using the sine rule. Two sides, two angles, including the thing that you're trying to find. And remember, if it's a side you're trying to find, you'd probably use this first version of the formula. If it's an angle you're trying to find, then you would use the flipped over version of the formula. Okay, cosine rule, let's have a look at this one. 1, 2, 3 sides and one angle. Okay, so it's quite different. The setup that you're given in the question from the setup you're given, it should be easy to tell which one you need. Remember to count the thing that you're looking for as well. 3 sides, one angle, and again, there's two different versions of the formula for whether you're trying to find a side or an angle. Now, it really will be worth watching the second video that I do on this, where I go through some examples, because I'm going to highlight something called the ambiguous case in the sine rule, which is where when you're finding an angle, you can get two possible answers, and you have to be very careful to make sure you're getting the right one. So this is we're going to come into the end of this video now, but please have a look out for the practice video that I will put out, just so that you are seeing all the little ways in which you can miss things, make mistakes, what misconceptions we can get. It would be worth seeing them all. Okay, so thank you very much for watching. If you found the video helpful, please don't forget to click the thumbs up button and subscribe if you would like to see more. I look forward to seeing you in the next one. Bye.